on to 931. I'm hopeful this one will be kind of short, but I guess we'll see. So now we're going to look at system of inequalities. You guys might remember from earlier when we had system of equations, it was just sort of like we would see where 2 points would meet and the intersection. Again, if it was a point here, it wasn't in a system. I'm sorry, it wasn't a solution to the system because it was only true for one line and not both. So we use like elimination, substitution, that kind of a stuff. Hopefully you guys recall that. I believe it's chapter 6, but I could be off on that. Anyways, now we're going to look at systems of inequalities. What do we do when we have sort of like these shaded regions going with this shaded regions? What's that going to look like? So that is our goal for this section. In chapter 6, you learn that the solution to a system of equations is a point that makes both equations true, but what about the solution of a system of inequalities? How can you represent these solutions on a graph? How many solutions can a system of inequalities have? Consider these questions as you learn how to graph a system of inequalities. So it's asking us to go back to problem 958 and look at our solutions for these two inequalities. And what it's going to ask us to do is essentially put these two things on a coordinate plane together to see what the solutions look like. And then we're going to answer a couple questions with it. If you've not done so already, verify your solutions algebraically by substituting in coordinates of points. And then how can you be sure that this region contains the only set of points that makes both inequalities true? So we're going to discuss problem 965. And again, it's one of those things where I'm going to jump over to a coordinate plane and do the entire problem. And then we'll come back and keep working on this lesson. So 965 starts by asking us to put this inequality and this inequality on the same coordinate plane. Okay, so my y-intercept is 5. I'm going to go down 1 and over 1. And it looks like it's going to be a solid line. And it looks like I'm going to graph below the line where y is lower. So I'm going to put them in this direction, kind of perpendicular. I think you'll see why in a bit. Actually, I can change colors easily. I think I'll do that. So let's go ahead and make our y-intercept -1 and our slope up 2 and over 3, up 2 and over 3, up 2 and over 3. It's a dotted line, so I am going to just sort of, sometimes I just like leaving the dots. I mean, I think you can clearly see what's going on there, but I'll put some extra dots in there just in case. I started to miss a little bit there. And I want to shade where y is greater than. So in this one, it's going to look like this. So now the question is, what are my solutions here? Well, it's got to be true for both. So over here, nothing is true. It's false for both. So I would expect any point I pick here to be false for both inequalities. Any point here I pick, again, the bottom one was the red one. I should have actually probably written that in red. And as a matter of fact, I think I'm going to change that real quick because I want to give myself a little bit of space anyway. So that's not a bad idea to just sort of rewrite this in red so we know exactly what the equation is, or inequality is, I should say. So it's going to look like that. So again, over here, I expect it to be true for the red line, but false for the black line. Here, I expect it to be true for the black line, but false for the red line. I expect all my solutions will come in here. So that's what I'm going to do. Questions C and D essentially ask like checking points. So we'll just do a little bit of math here. I'm going to go back to a black pen. This point is 10, 0. I expect this to be false for both. I'm going to go over here and plug it in. And you can see 0 is not less than -5. And if I plug it in here, I'm going to get, 20 over 3, which is like 6 2/3. So 6.6 minus 1. 0 is greater than 5.6. You can see that's false for both, just like we expected it to be. However, what if I pick a point like this one? 5, 5 is clearly in the part where I think it's going to be true here. As a matter of fact, let me pick 6, 6 instead. I don't know if you guys see why I'm going to pick 6, 6, But 6, 6 is going to be a lot easier to plug into this inequality than 5 would be. So anyways, it's clearly still in the red region. So if I go over here and plug in 6, 6, I get 6 is less than -1, which is of course false, which we expected it to be false. If I plug it in over here, I plugged in 6 because I plan on using a little bit of a cross canceling there. So I'm going to get 6 is greater than 4 minus 1, or 6 is greater than 3. That shouldn't be equal to. And you can see that actually ends up being true, like we suspected. It's true for the red line. It's false for the black line. If I go over here, and I know this is taking a lot of time, and by now some of you have probably skipped ahead if you even bothered watching this, but I still want to go through this whole thing. I'm going to go 6, -6. And again, the thing about 6, -6 is we expect it to be true for the black and false for the red. So let's go ahead and plug it in up here. -6 for the y, 6 for the x. I get -6 is less than or equal to -1. -6 is less than or equal to -1. That's true. If I go over here, by the way, I plugged in a +6, but it was negative, so it turned negative. I hope you guys caught that. I plugged in a +6, it just turned negative. Over here, I plug in a -6 and a +6 for the x. Cross cancel, I get -6 is greater than 4 minus 1, or 3. -6 is not greater than 3, so again, we expected that. True here, false here. And finally, the last one, we're going to pick a point that is going to be where it's black and red. And hey, look at that, 0, 0 is in the point that's true for both. So I definitely want to plug in 0, 0, and I expect 0, 0 to be true for both. So 0 is less than or equal to 0 plus 5. 0 is less than 5. 0 is greater than -1. That is true. So again, we have these 4 points in these 4 regions. This is false for both. This was true for red, false for black. True for black, false for red. True for both. That's how these inequalities work. I hope that makes sense. All right, let's jump back over here. And we can jump down to problem 966. So it says, draw a graph of the region satisfying both inequalities below. Start the graph with the boundary lines, and then test points to determine the region that makes both inequalities true. So I have y is less than x plus 2. And again, I'm just jotting these down because I'm going to run back over to the coordinate plane and solve this one. So I will run over to the coordinate plane, and we will do problem 966, I believe. And it was asking us to do y is less than x plus 2 and y is less than or equal to 10. Oh, and again, I probably should, let's go ahead and change the color there. Y is, actually, I'm going to give myself a little bit of room like I did in the last one. Y is less than or equal to, it said 10 minus 3/4 x, but I think most of us are comfortable having the slope first. So I'm just going to change that order. And again, it's fine as long as that's negative and that's positive. I can change that order. All right, so let's go ahead and graph this thing pretty simply. Y-intercept is 2. It's going to go up 1 and over 1. It's going to be a dotted line. And I'm going to end up shading the part that is less than, which is of course over here. Now for the red one, my y-intercept is 10, and I'm going down 3 and over 4. I'm going down 3 and over 4, down 3 and over 4. Looks like it's a solid line. That wasn't great. And I'm graphing below it. And again, I want to check a point that I think is going to be true for both. And hey, lucky me, 0, 0 looks like it's going to be true for both. Again, I could check a point here where it's false for both. I could check it here where it's point 1 true, 1 false, 1 true, 1 false. just opposite, and here where it's true for both. And I'm going to do that. I'm going to plug in 0, 0. I expect it to be true for both. 0 is less than 2 is true. 0 is less than or equal to 10 is true. So I'm real happy with that 0, 0. Again, I personally am not going to plug in points for all these. I already did it once. If you're taking the SAT, I would suggest you do it. If you're taking a test, I would suggest you do it. But other than that, I don't think we need to stay all day here checking points. There's an infinity of points, and it's not really going to help us that much to catch these mistakes, right? I mean, I guess one thing I will talk about is as long as I graph these lines correctly, then I should be fine. If I graph these incorrectly, then I'm not either going to notice. I mean, I'd have to check an infinity of points to start to catch my error, and it would be a pain. So anyways, I'm going to move on. I'm not sure I'm explaining that well, and I don't think it's worth the time here on this. So that was problem 966. That's great. Now we will go to 967. It says, how many regions when graphing the system of inequalities below? Raina started with the boundary graph of each constraint shown at right. So this is already graphed for us. By the way, I would point this out. This comes up like in tiny bit in integrated 2, but mostly in integrated 3. Essentially what we've done is we've taken like a normal exponential decline and just shifted the whole thing down 6. And you can see kind of that's what's going on there. Again, it's nothing you necessarily should know how to do already, but it is something that shows up in integrated 3. So, all right, so it says, why is the line dashed while the exponential function isn't? Well, the exponential function has the equal to, and the line doesn't. So, of course, the line should be dashed, and the exponential function should be equal to with the solid line. It says, find a copy of Raina's graph. How many possible solutions are there? Well, there's a graph right here. There's one possible solution for that section, a second one, a third one, a fourth one, and a fifth one. So there's 5 possible solutions that could possibly be true here. So kind of a lot going on. I don't know if it's better. Maybe I'll leave those numbers there. All right, now it says pick a point in each region and test the system of inequalities. I could do that, but I really don't have any interest in plugging it here, 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 and here. I think what makes the most sense is I'm going to go here, and I'm going to say less than. I'm going to change colors here. I'm going to go with I'll go with yellow and red. So this will be yellow. Yellow's not picking up very good, is it? Maybe I'll go with this color. This color for this one, and this color for this one, since I already have black being used over there. Okay, so it's less than this curve. Well, less than this curve, y is less than this curve over here. So I'm just going to sort of use what we talked about, that shortcut, because that's going to be a lot easier than plugging in points here. And again, that's the beauty of knowing more than one way to do something in math, is you don't get stuck having to do it the long way if you don't want, and I don't want to. So anyways, y is greater than this line. Well, here's where this line is greater than. So I don't know, maybe I should kind of do this. So if we look at these sections, I've already numbered them. Well, 1 looks like a good bet, right? Region 1 is green and red. Region 2 is only green, so no. Right, region 3 is only red, so no. 4 is in either color, and then there we go, 5 is green and red. So those would be my solutions on that. Finally, why is 0, 0 not a good point to check? Well, you'll notice 0, 0 is right on the boundary of 4. Right on the boundary of the line, right here. So there's no reason to check 0, 0 because we know it's a boundary and we know the boundary is false. That's why it's a dotted line. So hopefully that makes sense. Kind of a nice little shortcut we took. And at that, we will kind of finish this off. We're getting close to being done with this lesson. So we will go to 913B. Not letting me jump to 913B. It was just going to 913A again. So if I go to 913B, It says, how does changing the inequality symbol affect its solution? Notice that each system below uses the same boundary set as Reyna's graph from 967. However, notice that this time the constraints are slightly altered. So greater than or equal to, greater than or equal to, less than or equal to, greater than, less than, less than. So they've sort of changed some stuff up from problem 967. So what we're going to do is we are going to do the same thing we did on 967 3 separate times. They give us a nice little, what are these called? Recycling? A resource page. They give us a nice little resource page with which to do it. So, same thing on this one. I'm going to go ahead, I'm going to mark this one as the green, and I'm going to mark this one as the red. And I am going to number, I can't remember, I think it was 1, 2, 3, 4, 5. I don't know if I did that on 967 exactly in that order. I guess it doesn't really matter. But I'm going to have these different numbers for the areas that it could possibly be. And again, I'm going to use a shortcut. I'm not going to do it the long way. So greater than or equal to, this is where y is greater than or equal to. So green would look like this. And red is greater than this line, so that would look like this. And you'll notice on this one, 1's a no because it's red only, 2's a no because there's nothing, 3 is both, so 3 is definitely, 4 is green only, so no, and 5 is red only, so no. So in this one, it would be only 3. All right, let's go to this one. Greater than again, so again, I'm going to get the green looking like the following. And then the red is less than this time, so it's going to look like this. And again, 1 has none, so no. 2 is red only, so no. 3 is green only, so no. 4 is where they're both true. And 5 is neither, so no. And then finally, the last one, we will go to C. We're going below this time on the curve. And on the red, we're going below. So you can see 1's a no because it's green only. 2's a yes because it's both. 3's a no. 4's a no because it's red only, and 5's a no because it's green only. So this is what would happen if we change these inequalities. You can see it looks crazy, and I got to be honest, this it was nice having this resource page for sure. And then now to finish this lesson off, we are going down to here on 969. It says the United Nations. By the way, it kind of has some math notes, so if you don't like my explanation, feel free to look through those, or obviously Google it or whatever, Khan Academy, whatever it might be. United Nations asks every nation to write constraints that best approximate the country's shape. The UN thinks this will help find each country's area. Honduras sent in its constraints, but some of the information is unreadable. With your team, determine the missing parts of the inequalities and rewrite them on your paper. All right, well, this one has a y-intercept of 3. There's only one with a y-intercept of 3, and it looks like they shaded below it, right? Looks like they shaded below it, and it looks like it's equal to. So I'm going to say less than or equal to. Well, you can see that. Less than or equal to is what it says in that box. All right. The one that says y equals 2. Again, y equals 2 is this one right here. Again, it looks like they shaded below it or it's equal to. So again, that's what this box should say. This one has a y-intercept of -1. Now we have 2 with a y-intercept of -1, so we got to be careful we get the right one here. But the slope is negative, so we're definitely talking about this one. It looks like we shade above it. So I'm going to say greater than or equal to on that one. Here, this one doesn't have a y-intercept, so I'm going to jump down to this one because it has a y-intercept of 4. So they're obviously talking about this one, and they clearly shaded below or equal to. And then finally, this last one must be the one with the y-intercept that goes up. So it looks like they're shading above it or it's equal to. So just sort of using context clues in the y-intercepts and which way it was shaded. And again, that greater than less to that shortcut, so we don't actually have to plug in numbers every single time. The plug in numbers works, but I think it's nice to have that shortcut. Have a great day.